have a okay, and so welcome, Bhanu Mohanty, and we as Dr. Rayaguru said, it's a very relevant topic: artificial intelligence, machine learning, and it's kind of a little bit shift from what we were discussing so far in the Tea Talk. So welcome, and you have 30 minutes to. Oh, by the way, one thing that I want to see also, that you have a stealth startup in agriculture in India. So we maybe you will introduce that to us also during your
Yes.
talk. So we
Yeah.
are all excited about it. Okay.
Yes,
So
yes,
with that,
definitely.
yeah, yes, with that, off to you, Bhanu Mohanty.
Yeah. Thank you, Devasmita sir. First of all, it's very kind to give me an opportunity to talk in this forum. And means, as I said, I've been out after I did my graduation, went to IIT. After that, I have been in Silicon Valley now for almost 30 years. So completely out of touch with agriculture. But why now? So there are two primary trigger points why this interest means I started coming back to agriculture and I wanted to talk in this forum. One is the recent changes to AI/ML landscape. So before it was a hard science. So from my experience, I'll talk a little bit about that. Like how do we develop these AI/ML modules in my previous companies versus what's now? And especially, you probably all are of ChatGPT, OpenAI. So it's only 1 year that these whole large language models that have changed the landscape of AI/ML. And then second is the most interesting trigger is government of Odisha. So government of Odisha, surprisingly very, very supportive. So they want to implement AI/ML in very social impact use cases. And agriculture is one of the number one primary sectors they want to experiment that with. And then other sectors they want to explore possibility of, let's say, healthcare or women's education. So they have identified few sectors where they want to implement this. So today what I'll do is I'll quickly show the agenda. So this is my last picture in Hostel 5. Every time I go to Bhubaneswar, I try to go to Hostel 5. It gives so much of nostalgic feeling. Means I see you guys are talking about volleyball. I actually continued playing volleyball. I play in some of the leagues in Santa Clara, and all the foundation comes from Hostel 5. So about me, I'll skip that. Then we'll talk a little bit about AI/ML, general theory, and then why LLM and Gen AI, how that is relevant. Then digitalization for agriculture. And with that, we'll also talk about what is this stealth mode startup. It's very stealth mode, it's in ideation stage, but I'll tell what we are trying to do. And then some of the use cases we have identified for specifically for agriculture. Then we can keep hopefully 30 minutes for Q&A. So I'll skip this side. This is the introduction. Sar has already sent, so there is no need. So this is a very theoretical slide. What AI is, I'm also probably going to skip. But here, the primary two things I'm going to focus is on supervised learning and supervised learning. These were the most relevant machine learning algorithms which was used, especially past 10 years. So in past 10 years, if I see my career, I have been mostly in marketing tech stacks. So we create SaaS platform, marketing platform for different kind of industry. So every time we create such platform, so one of the key element is we have to do some machine learning algorithm to predict, to forecast, or to recommend some things. For example, I was in a restaurant tech. So we created a machine learning algorithm to recommend what kind of coupons we should create. Like, let's say you buy Jamba Juice or means one of the chains, or go to a pizza restaurant. So you buy a pizza, you get a beer free. So what are these kind of combination which attracts people and bring people more to restaurant? And similarly, currently I work for a company which does marketing for B2B tech companies. And they're, let's say, we normally visit to different websites, corporate websites, to learn about that company. And that time, let's say we recommend some blogs, we recommend some videos, we recommend some articles. So that's also based on a lot of machine learning algorithm. And that was based on these two fundamental principles of unsupervised learning and supervised learning. So this shows the difference between those two. So supervised learning basically says, I know the output, I know the predicted output, I have some historical data of what the model output is going to look like. In that case, what I can do is I train the model. Let's say I have some historical data and I train the model, and the output, I'll compare what it is expected to produce. So if I have this baseline output, then I can reduce the error. Let's say, so we say the confidence of the model. So it's 90%, then we start improving to 95, 98, 99. However, based on the amount of data we have. So that's supervised learning. And unsupervised learning is kind of a clustering or exploratory algorithm where we say, we don't know what the output look like, but cluster this data into some minimum, or let's say 5 clusters or 10 clusters. But here we don't know if the clusters are right or wrong. It is more exploratory. And here the error is reduced. So let's say we create multiple clusters. We say, hey, there is a centroid to the cluster, and make sure when you create a cluster, the distance of all elements around the centroid kind of as close to possible as to the centroid. And every time there is a distance is high, so that's the error. And during this machine learning, the goal is to reduce that error. So this is the classic machine learning algorithm we do. And typically, from my experience, again, actually, most of my startups in the last 10 years, I always have engineering teams in India. So recently, let's say I have my data science team is in Delhi. So what they do, it's actually a long process. So it took me almost 3 years to build this team and build this algorithm and train. So the entry to the bar of entry to AI ML was a little bit hard. So you find data science people, and then they write these models, and these are very purpose-built models. What that means is, let's say I was in restaurant tech when we build a model that only works for restaurant tech. If I create another model for B2B, tech companies, let's say forecasting or predicting, like a Netflix style, what should be your next video or what should be your next blog. So do you have a question?
Sandeep, we will wait for the questions later. Okay, let him finish the talk, then we'll wait. We'll have a discussion. Okay, thank you.
Yeah. So this kind of algorithm was very purpose built. So that means when we switch from one industry to the other industry, the whole process starts again, because it was trained for that kind of data, that kind of use case. And whether it is a mathematical regression model or is a whatever, any other model we create that is very specific to that. But what happened recently after ChatGPT and OpenAI? So they came up with a concept called LLM. LLM is a large language model. So what they did is, it's the next generation of machine learning, which is called deep learning. So they created a very huge, large AI model, which is pretty much trained on everything. So that means there is no need for these purpose-built models, one for restaurants, one for education, one for agriculture. It's not required anymore. So these large LLM models, they're pretty much trained about everything. They're the most probably now wise person in the entire internet history. So every Wikipedia, every books in the library, every website, they crawl, they get the data, they train this. So it takes them for years. Probably they have taken 4 years or 5 years to build this kind of repository and train the model. And so some of the popular models are GPT, obviously, is from OpenAI, then Google has some of these models. Facebook has created some of these models. NVIDIA is working on some of these models. And so all these companies, probably there are 10 LLMs now. All these companies says, this is my model and this is fully trained on any topic. So what it means is now, let's say I have to develop the algorithm for agriculture. Now I don't have to build a data science team and take 3 years to build such a model and train it. Instead, I have a starting point, which is almost 80 to 90% trained. So I can go to now a LLM and ask questions about agriculture. It will probably answer. So then the next step on this LLM is to train only specific context right now. So because it's so knowledgeable and it probably knows everything, so we call it hallucination. So you answer a question, there is a high probability that it will hallucinate. In my previous example, for example, I was in restaurant tech. So when we create this model, and then we ask a question about, let's say, B2B industry, that model will say, hey, sorry, I don't know the context. But if you ask LLM, it doesn't care which industry you are in. Means you can ask, for example, my current company, I have an app which is built on LLM. If I ask about agriculture, it will actually answer. And sometimes it's bad also because it will hallucinate so much, it produces bad result. So now the role of data scientist or the engineer, software engineer, instead of building the model, they want to narrow the model. They will say, hey, how do I establish a boundary so that these models don't hallucinate, and ask questions about my local context? For example, if I ask questions about rainfall in Odisha, what's the impact of rainfall to this year's crop harvest? So all these has to be narrowed down. That means I take the base model and train with Odisha specific data, and that's when it becomes more useful and it will not hallucinate. And then the second subset is called Gen AI. So Gen AI in past, if you see the classic machine learning, so it was the two types is it's a cluster, and the answers are mostly true or false or yes or no. But Gen AI is actually capable of generating new documents. Today, you ask him to write a poem, it will write a poem. You ask Gen AI to create a video out of his text, it will create a video. So this is whole set of new use cases where it's actually producing document rather than just understanding document and doing some classifications or clustering. So this changes the whole landscape of what AI and ML is going to look like in next 5 years. Okay, so the next topic I'll talk about digitalization of agriculture. And some of the starting point is, so here, University of California, Berkeley has a specific department. They help these growing countries or developing countries like India, Brazil, the BRIC countries. They say we have a department which will help you to devise a strategy for next 5 years, how to impact your society. So some of the ministers from Odisha and our IT secretary, and then we have a company called OCAC in Bhubaneswar, which is kind of the computer science branch of Odisha government. Every project is executed through OCAC. So the head of OCAC, they all came here to Silicon Valley. So we all met, we sat together. We also met UC Berkeley. So UC Berkeley kind of proposed an agenda saying that, hey, you guys have to do these things if you really want to be meaningful for next 5 years based on AI ML. And the best part is this was to our surprise. They're very supportive. The government is now very supportive. And we talked to most of the secretaries in Odisha. They want to bring AI ML. So they want to make it a curriculum to engineering colleges. And then they want to use this knowledge to build models for Odisha. So one of the first things UC Berkeley said, hey, you guys have to build a data platform. So today, what Odisha does is they have data distributed in different places, but they do have data. They do have data related to, let's say, mining, related to agriculture, related to corporate, financial data, healthcare data, but they're distributed everywhere. And it's not easy. Let's say the decision makers, let's say the IT secretary, if he needs to access some data, it's not very easily accessible to him. So that's why UC Berkeley proposed the first thing you guys do is create a data platform to bring all these data, which is located in different parts of systems, into one single platform, and especially with the modern infrastructure, modern cloud. These are very secured. We can use either Amazon Cloud or Azure Cloud. And the concept, we call it a data lake. So data lake is nothing but a huge storage platform where you bring in data from different places and store it in one place. So if you see the steps here we want to do is first you define a nomenclature. So there are a lot of definition of data we all talk about, but do we have the same understanding? For example, let's say we'll say, what's the definition of drought? What's the minimum rainfall which qualifies to be call it that this is a drought or this is a flood? So what is that meaning? So that nomenclature, so UC Berkeley said they will help to work with Odisha to define those nomenclatures. So once we have a baseline understanding of what the data means for Odisha, the second step is this data collection and validation. So now we'll go everywhere, try to get data. Where is this data for Odisha, and not just Odisha, elsewhere? For example, there might be a weather institute in Pune, which has the more relevant data specific to last 5 years of 10 years of weather data. So that's like a data enrichment. So you create not just the data which is relevant, sometimes data which is slightly related may not be exactly relevant, but has a meaning or an impact to make the analysis successful. So we can collect those data from elsewhere. And the best part is today the platforms are so open. I was experimenting with Pune Weather Department. They're selling their data. So you say, hey, you want every day this data to be done, or you want quarterly, you take the historical data, you pay some money. They have defined a process for this much money. If, let's say this is this much gigabytes of data, you download some frequent times durations, then they charge you, but you can collect those and load it to your data. Like let's say for us, we create one for Odisha, then that's where we'll collect all these data and keep it. Once the data is available in data lake, so then we can do some analysis and correlate them and create these models. And data consumption is mostly to make data available for the decision makers easily. Let's say you create some analytics, create some dashboards, create some aggregated KPIs. So today means they probably rely on still some people, somebody has to calculate and give them that report. But our goal is to make sure that, hey, they can have their information on their fingertips. They have access to devices, whether they're laptops or mobile devices. It can directly reach to them saying that, hey, this is the state of the affair, or this is the KPIs you want to track. So that's the consumption layer. And of course, after that, the feedback loop, if there are issues with some data and these decision makers can provide their feedback, which comes back to the data layer and helps in learning. So this is the data platform architecture. We call it architecture. Typically, what is behind the scene happens. So you can see on the top, there are different kinds of data store. And data stream is real time. For example, weather can be a data stream. That means continuously weather is changing, temperature is changing. We want that streaming data up to seconds, like what is happening. And then there are different applications. So Odisha actually implements a lot of applications in different parts. And again, through this organization called OCAC. So if we go to OCAC side, there it will show what are the different applications today Odisha uses for different parts. So we can now then go to these application teams and say, hey, let's build these connectors or data load process. Or event queues for streaming is typically an event queue. So it keeps adding to the queue, and you read the queue and then load the data. And then we can do a batch processing, stream processing. And once we have data in a format which is enriched, which is clean, then we can do business intelligence. We can do self-service analytics and run our ML models on top of it, whether it is a large language model, or we can still do some classic models with supervised and unsupervised learning. So all those models still we can run on top of this data lake. So that's our when we talk about our stealth mode startup, this is our fast proposal. So what we are saying is we are figuring out the team. So we want to establish a company in Bhubaneswar, an entity in Bhubaneswar. So this is probably my last corporate job. I want to wrap it up. And then almost after that, I want to stay sometimes in Odisha and build this team where we say, hey, one part of this team is building this data platform. And then second time we are telling the state, all the engineering colleges we have, let's train them on these real practical applications. So today means when I go, I meet a lot of engineering. I also recruit a lot of engineers to my companies. We still feel there is a gap between what they study at colleges, and especially on the software engineering side, and what they should actually execute in a real life project. So what we are telling the state that, hey, they need not go to Bangalore for searching job or wait for a project from US. So US is saturated. Means you know now probably Devasmita sir knows the condition of US. The most of the software industry is saturated. A lot of layoffs in companies like Google and big companies. Facebook, you take any big companies, they are not doing very well because it has reached that saturation point. All the scope, all these things are happening really in India now. So there is a reverse brain drain where people want to go back and do it in the state because state has money. State says we have money. We get a lot of money from mining and we want to spend that in these next generation technologies. And the state, it's very interesting. Like, I mean, at least from my experience now talking to all the secretaries, they are very, very smart people. Most of them are engineers. Their background, if you will see, they're engineers, MBAs from the best institute, and they really, really want to bring this difference to the state. So we want to embed the curriculum, which to these engineering colleges, and then say, hey, take these people and then create an entity which works with here UC Berkeley and then with Odisha State and build this kind of platform to start with a data platform where we have the baseline and then define use cases, which I'll talk a few of them. We say, which again with collaboration with UC Berkeley, which helps us creating such use cases. One of the thing they say is you have to come up with the innovative agriculture credit scoring. So we know in US your credit scoring is different. I'm pretty sure India has the credit scoring, but that may not be relevant to the farmers. If there is a poor farmer in a village and he needs a loan, how do we assess his credit history? He may not have a credit card in his entire life. So it's a very different model, very localized and built for agriculture, for your local farmers, considering the current weather situation, considering what was the yield, whatever his harvest was the last year. So all these taken into factor, create a scoring system, and then make that data available to the financial institute who can help giving him a loan or subsidy or whatever that program may be. The next one, we have identified voice-based expert advice for in local languages. With, of course, most likely it feels like now India, everybody has a smartphone. So they have access to devices which was probably not there 10 years before or 15 years before. So we can make the output of these models available to these farmers in local language. So they don't have to rely always on an expert to give these services. So it's a self-service delivered through local language voice. Then climate risk transfer innovation, launch of innovative climate insurance solution, access to continued agriculture credit and financial inclusions, improving crop yields. So there are a lot of IoT research is coming, like many ideas, like you plant these little IoT devices with plant or with soil, it can give you means collecting data, it has become also very commodity. So you put a little device in your soil, you know the water condition, you know the what, and collect those and do some analytics, do some learning. Then pest control, you can observe the situation of the plants and see how they're behaving and if there is a pest attack. So all these things now is a very possibility, and it's not require a very large team of scientists to do it. It requires like a few engineers and few devices, of course, support from Odisha government. That's the primary key. And the reason, a little bit selfish reason why I wanted to talk here also, because I know you guys are some of the finest people in Odisha who understands this domain, who has been there, who has seen there. So some point means probably I'll ask like if there is any interest, of course means it's now in a very preliminary state, but if there is any interest to help us and be that advisor to guide us, to bring that expertise and the knowledge you have gained through your career and help us help Odisha, and we all can build something meaningful which can impact our society. I think that's all on the presentation side I had. So we can now open up. And again, the stealth mode startup, we just established an entity. So I think it will be somewhere in Bhubaneswar. We are still figuring out how the structure will look like, and what the first project still we are identifying is the data platform. Irrespective of use case, we say, let's bring all the data together. That's our first goal, and put some analytics on top of it so that it is accessible to all people who makes decision. With
Well,
that, I open up for discussion.
yes, thank you very much, Bhanu. This was interesting abstract presentation for some, I'm pretty sure. Two things that I took out of, and before I hand it over to Sandeep, is one thing is you talked about, which is true. You talked about a reverse brain drain and other stuff because things are getting saturated. But underneath all of this, I believe the sensors and the intelligence platforms, they are also responsible for these saturation. Okay, I mean oversaturation. That means people. So I see that this trend is, and I have raised this issue before also. This trend of intelligence platforms and sensors and other stuff is going to replace human human beings that used to collect data, for example.
Mhm.
You know, in England, for example, the post they used in the remote areas, they used the postmen to go and collect. This was used to a long time back to collect
Right.
the rainfall data, okay, from the rain gauges.
Mhm.
So that thing will be replaced now with sensors, because now sensors can transmit through satellites. Zillion. Second thing is data storage. That will reach a point where data storage, even if we call it cloud, there is some limitations to cloud also, and that ceiling will hit at some point of time, with
Right.
India and China and Russia and other big G20 countries trying
Mhm.
to harness, the data portals and other stuff. So that was one thing. I forgot what is the second thing, but if I remember, I'll bring it back. But with that, I will turn it over. Sandeep had raised his hand, so let him start engaging with you, and then others can join. You have to unmute, Sandeep. He left. No, he didn't leave. Sorry.
Maybe on the mute. Yeah, just
Yeah.
to add to that reverse Brendan and the policies. So one of the exciting part when we do project in India, and means again, I have spent now most of my life in US, but US feels like very templated. Means you know this, Devasmita sir, you move from
Yep.
one city to other city, everything is same, right? It's just the name changes. You find the same stores. Process is very simple. If you have a purchase order or a vendor process or a financial accounts payable process, they're all same. But if you
Yeah.
go to India, every city is different, every use case is different. The challenges are so exciting. It's actually more exciting to work on projects with India and Odisha. Same thing, credit scoring. Credit scoring US is one standard. It's very easy. Like everybody can learn reverse engineer that algorithm and say, hey, I'm done. But to do that in Odisha or to do that in a local place, that's the engineering challenge we want to solve. And that's more exciting also.
But Bhanu, that's a good point. The thing is that these standards have not been developed yet in India. That's why the people call it a third world country, although it's not a third world country. But people call it a third world country because we haven't developed all these standardized things. What I'm afraid of is what I'm getting at, and what I just mentioned is maybe 5 years down the road or 10 years down the road, when we have everything standardized, which is happening more and more in banking sector, at least in India. Okay, this once the standardization is in place, then human labor will be replaced, and that's what I'm more worried about, is how that can be, how that what to do
Yeah.
about it.
Yeah.
Basically, social engineering. Okay.
Yeah, it's a very valid concern, and we talk about that. So, for example, means today, let's say I start a company of around, let's say, 50 million revenue. So, for 50 million revenue, I would say I need 50 engineers, 20 QA people, and that's my team. I need to build it. But in today's world, with this Chat GPT, it actually generates software. It's generating code. So now my boss will come and say, fire 40 people, because now you achieve 100% productivity or 200% productivity using this code generator. And this is scary. But now we are shifting the gear, saying that, hey, don't, AI is not going to replace engineers. AI is going to augment engineers. So the engineer's mindset now is, how do I make my day productive using AI? Not thinking that AI is going to replace it. I'm going to say AI is going to make my life easier to help produce more. So that's the pitch we are actually saying. But yes, very valid concern. People talk about it like, these jobs are going to eliminate it because it's going to taken over by some machine.
Okay, I'm not going to argue any further on this one, because
Okay.
others have a question. Bhanu, you
Yeah.
and I will talk over phone sometime.
Yes.
No.
Yeah.
So let's open it. What happened to Sandeep? He left. Maybe some network problem. Any other question? Anybody else wants to engage? Please unmute and yeah, show your face at least, so that Bhanu doesn't see an air. So go ahead, Chandranath or Kalpana, who was okay.
Am
Yes,
I audible, sir?
Chandranath.
I'm Ajit. Am I audible, sir?
Yes, you are Ajit.
Sir, actually, there is some problem with the camera of my laptop. Actually, I don't know why this video is not coming. So, sir,
Okay.
Bhanu sir, actually, I am Ajit, working as scientist in Indian Institute of Water Management located in Bhubaneswar.
Awesome.
So, actually, sir, it's like not exactly, and I want to discuss with this thing.
Mhm,
Recently, we are working on some project on some project in which we are estimating the ET0 by using some machine learning models. That is very static approach. We data
okay.
maybe 60 years data we take, calibrate,
Mhm,
validate. It's a very static approach. But
mhm,
what I would like to know from you is like, for example, this time in Odisha, the 10th exam, the matriculation exam is going on, and they are using
mhm.
AI based camera to show any normality change of behavior so that they can
Right.
identify that where the malpractice is going on, this and that. It's so appealing and to know how the AI is affecting reality in maybe education system, this and that. So actually, I from your side, I would like to know how do you think in the day to day, like for us, the most stakeholder is farmer or academician, especially in agriculture research. How do you
Mhm.
think, sir, particularly whatever, because we are more or less use it, but how do you think that kind of AI apps or something that can really change, especially in irrigation sector? We talk about Orissa or this area. In
Yeah.
day-to-day life, it's not about very academic kind of thing, but it's like
Right.
day-to-day life, how do you think that can change?
Yeah. So the way we feel is it has to start from the top people from Odisha. So that's why when these IT secretaries and some ministers came to UC Berkeley, they said the next step for them is to do a learning for them how this can impact to day-to-day life, because they want to learn also what is this AI ML buzz. It's just a buzzword academics or is it real? So there is a plan. There are some professors from UC Berkeley actually go to Bhubaneswar and have a workshop, 5 days workshop with government official to train these, saying that, hey, this is not anymore a education topic and sophisticated topic used by large universities or large companies. It can be used, and that's why they want to help us identify it from their experience. UC Berkeley has done that in other states also, like I think Andhra and one other state. And I have a colleague who works in Punjab who has done similar things in his state. He's also going to help us advise, but we are still identifying this day-to-day use case. That's why we said make it available in the devices or the which this farmer has access to. Like and the nearest device is a phone and smartphone. And smartphone today, with the size of the chip going down and the processing capability of the chips, it's very easy to do a lot of processing in your phone, which is probably not utilized. WhatsApp is the most used in India because now people know how to use WhatsApp. So similarly, we'll use such medium to deliver use cases in local language so that they don't have to know there is a big science or AI behind it. For them, it's a use case, and my day-to-day, I need this, I'm getting it from my device, asking question in my local language. Yeah, it's still a little far, but we are trying there. We are trying to get there. Like, what are these use cases? But then that's where UC Berkeley helps. Like they think they have experience. They have done this in other developing countries, so they can help us identifying those.
I have a question, Debai.
Mhm.
Can I ask?
Yeah, please, please.
Yeah.
Yes.
Bhanu, really, this is a very good topic. I have one two queries. Number
Okay.
one, as we discussed about the unemployment problem due to this introduction of AI,
Mhm.
the same story which happened at the time of when Rajiv Gandhi was the prime minister, introduction of computer, we thought that the things will change. There will
Mhm.
be massive unemployment, but it did not happen. Rather, it created a employment. So
Mhm.
maybe this, I think this AI, it will be, we have explored maybe 0.5% or less than that on the AI, still a lot to be explored. So only future can say employment or unemployment. I hope it will create employment. My question is, now we are partly also using this AI, chat GPT we are using. So
Mhm.
only question is for a unknown topic or a subject, when you get some result or report, so how will you ensure that this report is correct? Is there any check measure or any that's the question?
Yes, so we do that, and that's a continuous improvement. That's what I mentioned, hallucination. So a lot of time. So there is a new branch of engineering now. Suddenly, it just emerged after ChatGPT. It is actually called prompt engineering. So this engineer is able to frame the question in a way and then evaluate the response before. So let's say you go to ChatGPT and ask a question. You are asking your question and ChatGPT directly answering you. So we say that's a high probability that ChatGPT will hallucinate. So instead, we say we'll build a layer, middle layer, which is the prompt engineering. We say your question will be translated into the prompt engineering. Prompt engineering will formulate that question a little bit, make sure the context is
Yeah.
right. And then it will ask a question, and then it will also evaluate the score of the response before giving it to you. Because if it directly gives, it will be hallucination. So that's
Yeah.
the layer now suddenly is a new layer of software engineering. So everybody wants to be a prompt engineer. And today, most popular language is Python. So Python has created libraries. Say, hey, this is how you interact with ChatGPT. Don't expose ChatGPT directly to customer. Instead, you build your application, which has that layer to minimize the error.
Yeah. So that's required. That middle layer is required.
Yeah.
Another thing also, because without testing or anything, because for some reports, anything that we are comparing, we are getting one report from one platform, another report from another platform, and we are using some brain and finalizing the report. It's okay. But when we take the decision about maybe the agriculture in Odisha and other things, so this concrete, the report should be 100% foolproof, and it should be authenticated or validated with some baseline data or everything, so that with confidence this can be implemented, because we are very new to this area. We don't have much knowledge on this, and superficial those idea we are just throwing on you because you are expert.
Yeah, and I think that's a very good point, and that's why we say sometimes job will not go out, it will increase, because the final decision machine cannot take, no matter what. Means you need a
Yeah.
So it has to be a person. Let's say someone like you have the experience, you have seen this. No matter how much machine learning does, it's just providing, it just have access to more data, and it can crunch the data faster than a human being. But outside of that, the final decision, it should be you. So all AI should do is minimize error, produce the reports or recommendation to you, and you, the subject matter expert in this case, have the ability to make decision. And that, I don't think it will ever go away. It means we'll never reach a state. Means we all drive a Tesla car, it says self-driving in the best highways in the US, but then they have a button to override it, because they know that no matter what, it doesn't identify a yellow light when there is a sunset. Is it really a yellow light or is a sunset yellow light, right? That decision is given to the human being.
Correct. Thank you, Bhanu.
Yeah, thank you.
Yeah, Suranjan Babu has raised his hand. Suranjan Babu, you are on, but you are muted, so you have to unmute.
Oh, yeah. Hello. So thank you, Bhanu. It's a great talk. I'm a professor at Purdue. We have worked on AI for last 30 years for agriculture. Thank you. So my question is, you mentioned about company OCAC. Can you? So is it a Odisha company, or is it in California?
Yes. No, it's not a company. It's not a company. It's an agency.
It's Odisha's government. Yeah.
Odisha agency.
Odisha Computer Application
Center. So it is the Odisha Computer Application Center.
It's a government organization.
Yeah.
So how easy it is to have access to those data? That was my question.
It's actually not very easy. There are certain companies, for example, I know, means that's what we do right now. That's what we are doing. Which data is easily available, like a PET structure. For example, weather data, there is an institute in Pune, they are willing to give. But if you say Odisha data, it's not going to be easy. So you have to work with them. But if you see different states have different ways, right? So for example, if you go to Andhra, their state portal, much more data is available in their state portal than if you go to Odisha state portal. And if you and there are also, if you see OCAC, how do they do it when there is a project? OCAC is the primary government organization. We say, hey, I'm going to open it up for this tender. So you ask a company to do that data project for me. So then the most popular company is probably Pricewaterhouse, Deloitte. We know these big five. They take the project. Now we are saying don't give it to them. So do it in Odisha by Odisha people. Give access to them. Everything stays local. So yeah, but to answer your question, it's not easy to get data. Some states, some organizations have made it accessible. In US, it's easy to get data, right? You government data, you go, there is a data.gov. You will find lots of free data to train your model. But in India, it's still not at that state. And that's why for Odisha, we want to create that data portal where you say, hey, if it is a public data, let's make it accessible for other companies to experiment, or universities like you, let's say you want to do something on Odisha, now you'll not able to get data. So we'll say we will be that platform and say whether we monetize or not, that's a different story, but we have a single interface for other research institute to get data in case they want to study about Odisha.
So in UC Berkeley data platform, is the data accessible to people within USA or outside USA?
No, UC Berkeley is helping defining the strategy. They don't have it. So they are saying
they don't
hey,
have.
No, they're saying you need a unified data platform for your state before you do any machine learning or any analytics or any understanding. And then you need a company to do it. But in a normal practice, let's say they will give this project to some dealer. It becomes very business oriented. So we are saying, work with us. We are from Odisha. We have good intentions. We want to come back and we have experience in this. Let's build this. And we are connected to UC Berkeley because they are local in my place. So we are saying, help us defining the use cases. We'll build that platform for you in Odisha and make it accessible. And that's our stealth mode startup idea, to build that fast.
Okay. Because Debu asked a very good question, like you also mentioned nicely, that collecting data is a commodity. It is reaching there. It is in the agricultural domain. But the problem is that people's perception that if I have a piece of sensor, it is the God's message is giving. But that is the problem in agriculture. You have $5 sensor, $10 sensor, $5,000 sensor. Like Debu or my colleagues who are working in soil water, they get $2,000, $5,000 sensor to get moisture content. But now if you go to companies, I can challenge 5 companies, their calibration model is wrong. Then what happens is the John Doe farmer or Hari Maji in Odisha, they're januni that he cannot understand or she cannot understand the kono sense what that sensor is giving me. And if the sensor does not give the right information, everything goes to garbage. So that is the problem. So I wanted to see how, when you mentioned collecting data is a commodity, can you explain that? Where are you coming from?
So I think there are 2 parts to it. That's why there will be a layer which we call data governance, right? Sometimes the data quality and data governance is equally critical when you are collecting data. So let's say there is a $5 sensor which gives wrong data and has wrong impact. It will cause wrong layer of the entire data lake will be a mess because the data quality is not there. So we always build so if you see the steps we build, so after data storage, so in past there was a term in software engineering called ETL. So we do an extract, E for extract, and then T is transform, and then L is load. So you get some data, extract from some source, transform it and load it. So now we say, let's flip the switch. You extract the data and load it, so we call it ELT. So first extract the data, dump as is. So you don't worry whether the quality is bad or good fast. So because storage we think is still cheap, and especially with cloud like Azure, Amazon, petabytes of storage they can give. So once you have that, then build this data quality layer and the definition of nomenclature, make sure the data quality is good, that you put it to a real data lake, which is accessible to outside. Don't make these raw data accessible to outside, because there will be a lot of data errors or a lot of bad quality data. So you build that layer part of data platform, which has those validation, make sure that data quality is good. And some using AI, some using models, some using rules. So we have rules which say, hey, rainfall, let's say somewhere rainfall in Odisha is between this to this. So we build a rule. So it cannot be more than that, or it cannot be less than that. So that's a rule. You say if a data element is coming, then it must be something wrong. And in a very raw example, I'll tell, for example, we collect these point of sales data for restaurants. When I was doing restaurant check, we say, hey, if there is a coffee shop, if you get a check amount of, let's say, $50,000, it's a data error. It cannot happen. You cannot go to a coffee shop and spend $50,000. So you define some rules, what makes the data correct. So that way you have some boundaries, some sort of validation to say, make sure the data you collect you first collect it no matter what, but then if there is an error, you put it somewhere for somebody saying that, hey, I find an anomaly in the data, please do a human review and say if this is good or bad. Then in this case, restaurant, they said, oh, this was a mistake, somebody by mistake entered, so we have to reverse that transaction. And same thing, we collect the data from some sensor, we say, hey, this is continuously producing data anomaly, is it the right sensor, is it the right way to collect, should we review it? So these kind of governance has to be built on data so that data quality finally is good.
Thank you.
Thanks.
Chandranath, did you have a question? You are waiting.
Yeah, thank you. Fine, Namaskar. This is Chandranath, 2 batches junior to you in CAET.
I think I remember you, and Narendra Bhai, I remember you also. So a lot of things I still can recall in my mind. Yeah.
Yeah, so good to see you and your nice smart presentation. And also good to know that you will be coming to Odisha for your next assignment. And so yeah, right now I'm in IIT-Kharagpur. So my question was also similar to what was being discussed.
Okay.
Like about data accessibility and quality. So if I say, like, for example, in water resources, the government of India made a good effort in bringing together all hydrology, remote sensing kind of data in one platform, water-related data. And it still exists, and it's good one water resources information system. But if you still look at it, I mean, there are real issues now if you look at it. So if I go into that site, and after so many years to extract some GIS data, so those shape files are kind of not there. So when it was kind of planned in the initial inception stages, I mean, these things were somehow not taken care of. That you should have kind of shape files for basins, catchments, rivers, streams, and all. So, I mean, how important you think are the initial steps to reach the final goal? So, I mean, not only in terms of data formats, but accessibility, like, say, for example, Central Water Commission has still all these data under secrecy issues. So when you buy data from them, you have to kind of sign a undertaking, and still you are not sure. So places like Ganga Basin, Brahmaputra, and all, they are, I mean, quite impossible to get. But others you may. Same is the case with IMD and all. So that is one part. But the other part, really, as was being discussed, is the quality. So many times we see the hydrological data. I mean, once I was in Bihar and I went to a Central Water Commission office to collect the data. So I went on a Friday, and I was surprised to see that the data of Saturday and Sunday was already delivered. So that was because the data operator was supposed to be already on Saturday and Sunday, and he did his job prior to going home. So there are really, these quality issues. I mean, even if we flag these outliers, as you rightly told, inside that range also there are kind of some issues. I mean, it's very much unlike US, where you have really good quality data, and here we don't really have it in many sectors. Yeah. So your views on that?
Yeah, I think I fully agree. Data quality and data accessing to the right people, right? That's where we say, and I told also for some selfish reason, I wanted to come this forum because you guys are the experts. You have the knowledge. I mean, we'll all provide, let's say this is the anomaly it find, right? So in US, maybe data quality is a little better, right? If I say they know, let's say, for example, in US, the rules for my credit card usage, they know where I spend my money. They're all watching me, right? They all know everything, like even where I drive, where I fill gas, where I go to restaurant. If there is something extra which is not in my radar, they will flag me and say, this credit card transaction is blocked because it failed the rule. It is not normal. Now you have to confirm. So in this case, as a human, first I have to review and say, confirm, is it me or it is not? If I say it's not, then they will block that transaction. And that's where experts like you come in. So you automate it, and it's not an easy science, right? I mean, especially in India because the quality. But as I also said, collect all the data. First, keep it, right? But don't expose it yet to the decision makers until it is reviewed, qualified, and all the anomaly has been fixed and corrected. The only when by expert like somebody human, which is making that decision, then you make it accessible for the decision makers. All else, it will create more problems than solutions. But it's not an easy task, especially for India, data coming from everywhere. And it can be very different. It could be just like malfunctioning of a chip which produces something wrong, right? It could be any layer.
But Bhanu, is that this is where the perception of people at the agricultural level. Agriculture is a different industry than restaurant industry, than entertainment industry, and manufacturing industry, healthcare industry. The perception that because I am holding AI banner, everything will turn out to be great. Okay. And that is so dangerous that even companies are saying that, just like you mentioned, that ChatGPT can create code, why should I hire people? And then company are coming, I'm a professor, we train people to the workforce. So they are saying send people who can think, who can create algorithm, who can create next chatbot, not we can generate, we don't want programmer anymore. Like, that 20 years before, if you know Visual Basic, you get a job in USA. But if you now that does not happen. You mentioned that. But my question is, it is important to know what that tiny device is that is collecting the data. Why do you have to waste your time to collect the data if you don't know what is the capability of the tiny device collecting the data? It is giving garbage, or should you collect garbage and say we will filter it? There is no point in filtering garbage if you know that it is garbage. So how do you know beforehand? So agriculture market, I think I wanted to know from your perspective, because that is the problem. Because just the students are saying, sir, Google told this, the ChatGPT told that, then professor is wrong, ChatGPT is right.
Yeah.
Right. And how do you draw the dimension? You see, like last week notice, there is a ChatGPT billed too much money in New York, and it is a lawsuit. Right. Yeah. And so then that is the part. But what Dr. Chandranath is mentioning, that good data quality. But our in egg sector, when the cost is a parameter, economy is a parameter, a farmer, Hari Maji, cannot go and buy $5,000, $2,500 NMR based sensor for measuring moisture in peanut field. It's just impossible. Then how do you, if you are making the decision based on the data, but if the data producing device is not reliable, then everything backend, downstream is difficult.
Right. So I have a slightly different viewpoint on the data collection part. I still think, fully agree on your assessment, and that's why agriculture is a different industry than from our experience, and that's why again I came to this forum to learn these things from you. Right? These are the valuable input I'll take now and research. Like, so the theory we already last 5 years, 10 years we did is, no matter what, we said flip the switch, collect the data, because from source is extremely hard, because we don't want to build a lot of intelligence on the source. You say collect raw data, because to build intelligence, you need more power, computing power, right? So that's why we say collect the data, bring it to a higher computing power where you can run more intelligence. So again, possibly you are right, and that's why this is a very, very valid feedback. I'll go now and research, like, what is the cost of getting data from a device without validating versus building some validation at the device layer. So that is one part. And second, a farmer cannot afford and make this decision. That's why we want to work with Odisha. I mean, we don't want to make an independent private startup company for profit saying that, hey, we'll directly go and do this. We just want to show some numbers. We don't want to do that. It has to be from government willing to invest, saying that, hey, this is the device I'm going to give, because this is going to help me improve my economy. And surprisingly, every time I read about Odisha, this is one of the very strong states last 5-10 years. And especially if you see the sports, what our chief minister did, means we feel so proud to read this. I feel like they're ready. They want to embrace this technology. Even one point we talked about, should we even have a, let's say, semiconductor or a chip manufacturing plant Odisha, and why not? Right? So there is every possibility, and they are open. But it's a very valid point. I don't have a clear answer, but so far what we have done here in part of my other industry vertical is we collect the data no matter what. We say bring it to a larger compute, then you apply algorithm, because all the rules and algorithms are central. So then we call it like a bronze lake. I mean, in data lake, there is a concept called bronze lake. So that's raw data without validated. But then once you validate, we could call that as a silver lake, and then gold lake. Gold lake is where you say, I've purified all the data, and that is what decision maker to see, because that's gold. That's all the quality has been applied from bronze to silver to gold. So that's the concept we have used. But of course, agriculture, everything doesn't fit. We have to research, we have to learn, and getting help and feedbacks like this will help us to get there.
Very, very good discussion, actually. One thing is, even with sensors, for example, I record my blood sugar level on a continuous basis. And I do it with one device. It gives me something. I poke my finger and take the reading. It gives me another reading. Okay. So I ask, I always question what I get. So, but that's sensor part. I'll come to the other part, which is the data ethics, not quality, which Chandranath actually brought up a little bit. But I want to give Devashish a chance to ask you a question. And this will be probably the last question. So, Devashish, go ahead. Yes.
Yeah. Thank you. Thank you, sir. Very nice talk, and I was listening to all the comments that's being made. So I'll just bring a student's perspective that I've faced. So let's say, and I'm just bringing this perspective because I think it's important to understand the differences that I've faced between the data that's available here in US versus what's available in India. The thing is, let's take an example. Let's take an example of satellite data sets. Okay, satellite soil moisture data sets. Okay, let's say SMAP. I was part of the validation campaign in one of the validation campaigns of SMAP, right? So they do these validation campaigns every 3 to 4 years, just to check the accuracy of data sets and the sensors that the results that it's giving. So it's a validation at the sensor level, right? I'm not talking about how you curate the data and how you sort of process it. I'm just talking about on a sensor level. Do we, and I'm not sure as far as in India is concerned, as it was mentioned earlier also, that if the data is collected manually, right, it is prone to manual errors, and the person who is there, it comes to their ethical standards, how they are sort of putting it. So do we, and if you are looking at Odisha, is Odisha government ready, to make investment in installing sensors so that we have a second layer of information instead of just collecting manual information where we are prone to manual errors, right? Because I genuinely feel that a lot of people are not educated, those who are at the helm of this responsibility, and they are just said, okay, take this measurement at this point of time, and they, because they might not want to be there at this point of time, and they just do something. So this might compromise a lot of things. Second thing I was thinking is the topic that was discussed about jobs and all of that. I believe, and it's I want to gauge on your opinion, is do you think that the students, let's say in our own college, right, CAET, are we training the students in somehow so that in future, where we know that people should have the ability to understand and run these large language models, or in this entire genre of machine learning, right, where not only this, you see GraphCast by Google, you see NVIDIA coming with its own sort of climate models, right, where they just take data assimilation and train it using machine learning and forecast predictions about climate, right? So are we sort of training our own students so that we at least make them capable enough to be in the market, to be superior in the market, right? These are sort of two things that I was thinking to ask you.
Yeah,
And
so I'll
others.
quickly answer. Probably we are seven. So I'll take 2-3 minutes to answer both questions. The first question, my belief is Odisha government is ready. First one, I think they are going to support. And the reason why we are optimistic is because of a intermediary organization, which is University of California, Berkeley. And they are going to say that, hey, we have done this. And that's why they are going. And in fact, they have officially signed an agreement. Odisha government already has paid UC Berkeley to help educate them. What is AI ML? What is the details? So that's why UC Berkeley, some people, they have made one trip to Bhubaneswar. They will go one more time and then train these top layer decision makers to understand that. And then second, coming to education, at least from my experience, because I do a lot of recruitment from engineering colleges. Means I have to say I have not gone to CAET yet because of the my most of the startups were related to software engineering. So I have made a lot of engineering and they are not. So they are not educated in AI yet. But so as I told, I have a colleague who works in Punjab and he's headquartered in Delhi. He does that in Punjab. Let's say in Mohali University, he has a specialized curriculum. And he actually puts in my project. He will say, hey, these are the students, you learn LLM, but a real life project, and he will put it in my project. So I have around 10 students every year, which working in Delhi, get a chance to work on a real life project learning LLM. So he's doing that by himself. He's a professor. He has a PhD in AI from Oxford University and then in Delhi. So he has implemented that in Punjab. But in Odisha also, I see in other universities, they have a budget, big budget. Means someone was telling one of these IT secretaries, I think they have invested so much in the CET, our counterpart College of Engineering Technology, which has a different campus. They said they have invested a lot of money for AI ML curriculum. But this is something also we want to see, like, can this be extended everywhere? But we'll see, time will tell.
Well, unfortunately, we have to stop the discussion now. We ran out of time. But we have the CATN's forum, both in Facebook and in WhatsApp. We can continue discussion over there. If anybody has any pressing questions or comments, they can put it there, and Bhanu will be happy to answer that. And all of you, those who have engaged today, thank you. Bhanu, it was an interesting, very interesting presentation. A lot of information, and we had a peak time of 33 participants. So which is a record. Even Chandranath didn't have that much. So it was and then all the best with your startup, and we can talk more, Bhanu, because
Thank you. Yeah.
I think you are in US. I can give you a phone call and talk more about it. Chandranath, I will catch you up sometime.
Sure, sir. We will discuss. Yeah.
Okay. So
Thank you.
with that, thank you, Bhanu. Yes. Thank you.
Thank you. Really appreciate for this opportunity and super excited to continue engaging.
Yes.